So hello guys, and welcome back to my channel. And today I'm making a new video, and today we shall be looking at the ultrasonic sensor. Here it is, the ultrasonic sensor, this one. We shall be using it to control a pair of LEDs. There are some LEDs here, you can see them. We have this LED, this is the first one. We have the second one here, this one, the yellow one. We have this one over here, this is the third LED, and we have the fourth LED. So just a quick remark, this one is a blue one, it produces a blue color. Then this one is this one over here, this green. This one is yellow, as you can see, it's a yellow LED. And then this one over here is the red LED. This is the Arduino board that I'll be using. I'll be using at Mega 2560. You can see it. Let me bring it closer so you can see. I'll be using this Arduino board. This one, for maybe some who are new to it, this is the breadboard. This is a breadboard, and these are the jumper wires. I've already made the connection, so everything is set. Yeah, all these connections over here are for the project that we are going to be doing today. So first of all, I'll be explaining to you about the physical connections, how to connect the LEDs and the ultrasonic sensor to your Arduino board. So first, this ultrasonic sensor, it has four pins at the back of it. You can see them well, but you can see that from it I have taken from it like around 4 jumper wires. You can see the black one, the white one, 2, the green one, 3, and finally the red one, which is 4. So to explain, first, this black one, this one, the one I'm holding, this one, this black jumper wire is coming from the ground of the ultrasonic sensor. Then we have this white jumper wire, which is connected to the echo pin of the ultrasonic sensor. The echo pin is the one that receives. Remember how the ultrasonic sensor works? It emits a high frequency of sound waves, which then reflected back to the sensor, and by that one we can be able to use the ultrasonic sensor to measure the distance of an obstacle or an object which is far away from us or from where we are. So this one is the white jumper wire is connected to the echo pin, and then we have the green jumper wire, which I have connected it to the trigger pin, the trigger pin of the ultrasonic sensor. You can see that the ultrasonic sensor here, it looks like it has 2 cylinders. Let me show you. You can look at it well. It looks like it has 2 cylinders. So one of them is the one that emits the sound, and the other one is the receiver. So we have a transmitter and a receiver. So this green one, the trigger, is the one that emits the high frequency waves of sound. Then we have this other red back here. This is the red jumper wire. This one I have connected it to the VCC, of the ultrasonic sensor, and now this the VCC of the ultrasonic sensor is now connected to the 5-volt pin of the Arduino board. Here it is. Then the ground is connected to the ground. Then the two jumper wires, the one coming from the trigger and the other one coming from the echo, I've connected it to pin number 26 and pin number 27. Those are digital pins on the Arduino Mega 2560. So if you are using any other type of Arduino, you just have to connect it to digital pins. It will work quite well. The digital pins I've connected to are not PWM, just to make a clarity on that. They're just digital pins. they do not have the PWM functionality. The other thing now are the LEDs. So as I told you, I have 4 LEDs. Now each LED, you can see, for example, let me use this one. This is the one I told you is a blue LED. You can see that it has this black wire. This one is connected to the ground of the Arduino. I've connected to the ground of the Arduino Mega, and then we have a resistor here. This resistor today I'm using 220 ohms resistance. So this resistor is the one that is connected to the digital pin. Here we take using this jumper wire. I've connected it to the to a digital pin. Actually, I've used digital pin number 25 for the blue LED. The reason we are using a resistor is to prevent you know that an LED, most LEDs support up to 20 milliamperes of current. So we don't want the LED to pass, or a lot of current more than that, the required current to pass through the LED, because if it does so, the LED will burn out, and we don't want that to happen. So use the resistor to regulate the amount of current flowing through the LED. That's making sure that our LED will not burn out in case of the current is more, so the LED is safe. The same I've done with the other one. You can see this one I told you is the green LED here. Let me zoom for you. Yes, like this. I think you can see very well now that here it is. You can see that along this line, I've connected it to this resistor, which is the one that is using now the purple jumper wire, and it's connected to the digital pin. I can trace it for you and show you exactly so you can be sure. Here it is. Okay, so guys, that's how it is. And the same I have done with the other LEDs, the yellow one, and this one is the red one. So without that said and done, so you might be wondering, so I've shown you all that, so what is the essence of all this? So now here we have the ultrasonic sensor. Remember, the ultrasonic sensor measures distance, and then it sends, we can be able to retrieve the value of the distance in our Arduino board. So here I have divided the distances in ledges. So when an obstacle is at a distance of 45 centimeters, between 45 centimeters and 35, then it is above 35, but at a range of 36, let's say that 6 to 45, the blue LED will go on. Okay, the blue LED will go on. Then if an object appears at a distance within the range of 25, above 25 to 35, then the green LED will go on. And when the green LED is on, all these other LEDs will be off. That's the coding for today. All these other LEDs will be off. Now, when the obstacle appears at a distance above 15, that is from 16 to 25 centimeters, then the yellow LED will go on. So it is telling us the obstacle is coming nearer. Actually, the arrangement of this light from blue to green to yellow, I was trying to assume it's like an obstacle which is coming nearer, and we want to alert our user that is like something like danger. So I was trying to use that's kind of correlation with the purpose. So but the main aim is to show you how you can be able to maybe use an ultrasonic sensor to do something useful, or to give a certain a measurement, or to do a certain thing when an obstacle is detected. So when an obstacle is between 16 and 25 centimeters closer to our sensor, we can call this breadboard of ours, let's call it maybe a car or something that we want to prevent collision from. So when the sensor detects that there's an obstacle which is in the range of 16 to 25 centimeters, it will make the yellow LED go on, or it will switch it on. It will switch it on, and when the yellow LED is on, all these other LEDs will be off. As I said, you can light your code that the other LEDs will remain on, and it can be like, you know, like they are lighting on without going off. But for this video, I decided that all these others should be off, and each LED will light at a time within the range that I have specified in the code. So then we have this other one. This is the LED LED. Now when the obstacle is within the range of 5 centimeters to 10 centimeters, from 5 to 10, then the LED LED will light. Now if the obstacle is not in those ranges, that is, maybe it is above 45 centimeters or it is below 5 centimeters, then no LED will be on. So that is the programming for today. So now let's see that in action. Actually, don't mind that, just a misbehavior. So guys, now let us see that one in action. So actually I decided to be using this white paper as my object. I could try using something else. I hope it just works fine. Yeah, the project is quite working, but I've not tried it with this paper, so let's do it together. So now I will bring my object and let's see what happens. Let me bring it to, so closely you can see the LED is lighting. Let me put the object well. Remember, if the echo is not, let me put it well, there it is. So the LED, look at it, it's quite on. Imewaka. So it's on. So what happens if we move our object further? You see the yellow LED, it's lit on, switches on. If we bring it much more closer, the red, then yellow. You can see my paper. So if I take it much more closer, so what do we have? The green LED. Okay, so if I take it much more closer, I mean further away, let's continue looking. You see the blue LED light. This means we are in the range of 35, I mean above 35, from 36 to 45. You can see where my hand is. Now if I take it further and further, it goes off, means I am above the range. And as I told you, when I am above the range, no LED should be on. If I start bringing it closer, I enter the range of the 36 to 45. So the blue LED lights. So there it is. You know, I'm not steady, so maybe that why. So then I can bring it closer, the green. As I come closer, the yellow. Yes, as I come closer, the red LED lights. Now remember, if I go below the 5, it should go off that way. So it is above 5 to around 15. You can see that there is the red LED, and then if I go further, it goes to the yellow. So now you might be wondering, what is happening? I mean, which is the code that has been used to create such an amazing project? Guys, now let me show you the actual code that I have written. Actually, in another later video, I will be taking you step by step in writing this code. But for today, let me explain you the code that I've already written. So let's come to my computer and let's see the code. Okay. So here you can see I've declared some variables. Let me show you. You can see the code. Let me zoom a little bit so you can be able to see. Guys, I want you to see everything. Okay, so you can see the variables I've declared. The code is a little bit wrong, so it's integer like red, yellow, green, blue. Those are the variables for the pins of the LEDs. Okay, those are the variables for the pins of the LEDs. Then we have the unsigned long. It's a variable known as duration. There's a reason you've used the long. I will be explaining it as I go line by line in the code. You can see another variable known as distance, an int, the echo, the trig. Then now I've created a function known as ultra-LED. It's a void function, so it means it doesn't return anything. Each time you're declaring a function, or you're creating a function which is meant not to return anything, you just use a void. So void, it's an ultra-LED. I call it ultra-LED. Then in here is where I write all the code, or I put the code which is to control the logic of working, or the workings of the ultrasonic sensor and the controlling of LEDs. Guys, this is always very important to declare a function. To declare a function before you even enter the void setup and the void loop of the Arduino syntax in your IDE. It's good to just declare a function up there and write all the workings of what you need. This makes your code not only readable but also easy to debug, because you can just go to the actual function which controls certain a task, and you can be able to make the changes if you want to do later on. So here you can see the first thing is it's to digitalize the trig pin low. The trig pin is always high, like most of the times it's high. So the first thing we do is to take it as a low state for like 2 seconds. The delay microseconds is 2, that is true, microseconds. And then we take it high again, delay again for 10 microseconds, then we take it low. That's the logic. Then here you can see that the duration is the duration variable which we had declared. We are now doing an instantiation of this variable to store the pulsing function. The pulsing function, what it does, it returns the amount or the duration of time in which the echo pin has been high. Here we wanted to get the duration of when it is high. You can also get when it is low, but here for us we wanted to get it when it is high. So it always returns it as a very long number in terms of microseconds, very long. So that's why we use the int long to be able to store all that value. Because if we would have given the duration or declared it with an int type, it didn't store all the values, and that would lead us to having a lot of inaccuracy in our measurements. So you can see everything. You can see the ranges of the distances. Guys, I hope you can see everything. Let me try to zoom for you a little bit. Yes, I want you to see and witness everything. You see the code, each and everything here. I take you through all the code. All these I've used the logic, else if statement and all that. So I hope you guys can see everything. Yes, everything. In the voice setup is where I've defined the pin modes. You can see, guys, I've defined the pin modes in the voice setup. Pin mode LED is the output, here is the output, green is the output, yes, blue is an output, because we are giving them voltage, so they are just output. Trigger pin is always an output. The echo is an input because it's receiving the when the sound hits the object, it is when it is echoed back, it bounces back, so it has to take that frequency that has been received. So then in the void loop, in the void loop is where we write the code which we want to be learned continuously, repetitively. Every code that is written in the void loop is always learned repetitively. So here we will just call our ultra LED function. So if we call it in the void loop, then it will be called continuously. That's making sure that our code is working continuously as we use it, and it's learning repetitively. So guys, that is it for this video. I hope you have enjoyed it. I hope you've learned something, right? You've seen the code and you've seen everything. You've seen how everything is working here, and it's such an amazing thing. Now imagine what you can do with this. Imagine like doing better things, like coming up with a project on the road. Maybe we could have saving power on the street lights. When the cars are approaching the lights, maybe the lights could be turning on and off as the car leaves. So these are some of the implementation you can try coming up, and use an ultrasonic sensor for maybe object detection or collision, to avoid collisions. All these things are possible using an ultrasonic sensor, and you can do quite amazing project with this. So until next time, I wish you guys quite a good time, and don't forget to like, subscribe, share, and comment on these videos and everything that I've been doing. May you comment and tell me what you like about the videos, what you like to see, and much more is on the way. So until next time, I wish you a good time. A bientôt. Au revoir.